Hi, I'm Philip Pearson. I'm coming to you from Mountain View, California. Tonight I'm going to be soldering up a few of these circuit boards, Arcflash version 3. This is a flash ROM emulator for Acorn Archimedes and A-series machines from the 90s. I'm making this video to show that not only is it possible to solder relatively fine-pitch BGA chips at home, it's actually not all that hard, and it's relatively reliable. This board here has a Xilinx CPLD, 0.8mm BGA, and two flash chips in, I believe, 1.0mm BGA. So nothing ultra modern, not like the latest tiny FPGA board, which has, I believe, 0.4mm BGA. That's where things start getting really hard. I find personally, when soldering these boards, the chips that give me the most trouble are the 0.5mm and 0.65mm leaded chips. Probably it's this one here. It's a 7.4 LVC125 buffer. I'm likely to bridge these pins together and possibly the pins on this micro USB connector. Anyway, step one is to stencil solder paste onto our boards. So here is the stencil for this board. It's the one that you get when you order circuit boards on JLC and just click the stencil button and pretty much accept the defaults. It's a stencil for both the front and the back of the board. I don't actually mount any of the components on the back of the board. There's a number of resistors here, capacitors, some decoupling capacitors, which I mounted directly underneath the BGA chips, but it turns out they operate just fine surrounded by decoupling capacitors on the outside, and you don't need them right underneath. Looking at computer motherboards and such, you'll see a sea of capacitors right underneath the chips, but it turns out for these relatively everyday components, that's not as necessary. So, peel up the edge of the stencil. This one's quite stuck, so there we go. Bring up the edge of the stencil, stick the board underneath. I'm actually going to make 4 boards, so this process may take a little while, but you basically you spend the time to kit your components out once and make a bunch of boards. It's fun. As you can see in the image here, today I've tried to get some better framing on my video. My video the other day making the Postbox V3 board, you could barely see what I was doing, but now I have this great big camera right in my face. So I could see all the pads on the BGA chips through here. I'm not sure if that's visible in the video, but it's pretty important if you want them to actually solder. Now I find that I have better luck soldering the BGA chips than all the others. And I wonder if maybe it's because of the amount of time I spent obsessing over getting the correct landing pattern for them. Reading the package manufacturers all specify in great detail how you should design your land pattern. There's two things. Confusingly, they call them SMD and NSMD. SMD means solder mask defined, and NSMD means non-solder mask defined. Now, an SMD landing pattern means that the pad is a little bit bigger So the pad is a little bit smaller than the solder mask opening. I'm having fun with autofocus today. There we go. Look at this. This is lovely. If you look at the BGA pads there, you'll see that they're all nicely covered with little blobs of solder. Ooh, I may have missed. No, it looks like we are good. I thought I'd missed one on the CPLD, but no, actually it looks good. Okay. That was pretty good for the first time. Usually, the first one I do is less successful. I get better through the session. Okay, so let's try to see. This board has four giant pads in the corner for a couple of diodes. So I usually orient on them and wiggle it back and forward until the BGA chips just light up. It's not happening today, not happening this time. Now there are all sorts of tricks to automate this. Basically, you have it so that there's a hole drilled all the way through your board, and also have it so that it's drilled all the way through the stencil, and you can just drop a peg right through the whole thing. That sounds lovely. I've never managed to pull that off in practice though. Ah, I see some metal. Almost. Okay, this might be it. My lighting is interesting today. Okay, let's try that. Something else I did since the last video is clean my spatula really well. Which is to say, I got out an old kitchen knife. I scraped off all that old hard solder paste, and then I wiped out what was left with a ton of rubbing alcohol. Okay, how are we doing? This one also looks pretty happy. Is that showing in the video? Yeah. You could see BGA pads with nice little bumps. Great. That's our second board. Third board. Okay. There's those diodes. Oh, this is not quite it. Okay. That looks pretty close. Wipe this on. Starting to run out of solder paste here. If I'm lucky, I'll be able to scrape this all up and do that fourth board. Fingers crossed. If I'm unlucky, I'll make a hash of one of these. Oh yeah, this one's a bit messy. Okay, so look at those resistor packs. Those are just big blobs of solder paste. But BGAs look great. And the reason this is awesome is I can fix the resistor packs with solder wick later on. Whereas the BGAs, I get one chance. Okay, let's see. Board number 4. Oh dear, I'm going to need a lot of passes to get this right, which means mess. But if you carefully apply your solder paste, and when you pick up your stencil, it's all a huge mess, all you have to do is put a little bit of rubbing alcohol on a kitchen towel, and it'll all come right off. Okay, there's a little flakes right at the end there. Cross my fingers. What have we got? We've got some of the BGA balls look a little misaligned, but it's pretty close. Alright, I am happy with that. Ready to go. Okay. So, as with the postbox boards, I have a printout of the bill of materials with repeated components marked in, and I'm just going to assemble these, usually easiest to hardest. So let's see what we've got. I see a bunch of tricky components. Let's do something easy. Okay, a whole lot of capacitors. We need 3 1 microfarad capacitors per board. Remnants of a reel right here. So, 12. 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12. And we're looking at C6, 7, and 12. I also have a little cheat sheet here, a printout of it, and we're looking at 6 and 7 are the ones up top. I actually wrote them in silver, you can just see it, 6 and 7, and then 12 is down the bottom. So, I'm gonna bring might help doing it the right way up. Six and 7. There you go, and you can see it. And 12. Oh, great. Doing a bunch of boards like this means moving them around a lot, so we'll get to see exactly how sticky the solder paste is. Alright, there's our 1 microfarad. I believe there's a 10 microfarad, which is C1. Pick one up there. Small pile of components over here. It's interesting, I believe this board, while somewhat scarier to design, actually may have fewer components on it than the post box. That thing ended up needing endless revisions for protection against miswiring or misbehaving target machines. Not that Arcflash hasn't had the same treatment. I've had all sorts of fun with this thing attempting to power a target machine through its data bus, which is why we're not going to fit one of these diodes, and is why we have those resistor pads. Now, what else have we got sitting around here? Oh, I see a microcontroller. How about the regulator? The regulator is way up in the annoying space underneath that camera. So if I can take care of these now, I can focus on the good bits. These things are fun. They are SOT89 format regulators, but that can supply rather more current than the MCP1700T chips I use on almost all my boards, because this CPLD is spec'd to draw rather a lot of current in the worst case situation. Now, I believe I don't work it nearly as hard as that, but this board can indeed draw rather a lot of current if you ask it to. Alright, okay, so what would be a sensible thing to do next? How about the big decoupling capacitors? Now there's a bunch of these. I believe there's 7 0805 100 nanofarad capacitors per board, so we're talking 28. Counted those out right. Now, these are all over the place. These are the red circles. Now, just for fun, I decided it would be a great idea to use 0402s to decouple the CPLD. This made the circuit board design a little easier, but oh, are those not fun to place. Now, what's next? 10, 11, and 13. Now, I bought a reel of these 100 nanofarad 0805s many years ago when I was doing a lot of LED projects. fact I still do. For example, this. It turns out the addressable LEDs used in this board, all of these here, the latest version of them seems to have internal decoupling. I'm not quite sure what that means, as I don't see any capacitors fitting in that package, but I may burn through. May not burn through quite as many of these little chips as I used to. Alright, that's some of our decoupling dealt with. Alright, well, it's hard to avoid it. I think I'm going to have to start putting some of the bigger chips on. Let's do some FPGAs. Where is my little pack of those? Here we are. Fresh little bag for them from DigiKey. Okay, what have we got in here? Oh. Here we are, 10 very nice little CPLDs. They've thankfully not been discontinued like my other favorite BGA chip. Now I know I put pin 1 markings on my boards, but just in case. Here's one from the previous Arcflash version, can see that the Xilinx logo, camera, you can do it. Xilinx logo goes straight across. So this is the trickiest chip on this board. All you got to do, assuming you're obsessed enough over the footprint, is drop it down. Nudge it a little so that more or less matches the silk screen. Now, one of these days I'm going to do something clever and put some marks on the silk screen and some traces that match up with them so that I can look at a board and see if the silk screen has registration problems, but it's not today. I do have some of these little fiducials for automated assembly. Sadly, I don't have a pick and place machine. So those are just there for the day. When someone gets tired waiting for me to make them one of these, it goes to someone professional. Well, there we go. That's 4 of the tricky BGAs. Seemed to go on relatively uneventfully. So of course let's follow that up from 8 of the easy BGAs. Crossing our fingers that they work just as well. Alright, here we are with a ton of little flash chips. A ton of little flash chips. Now each of these is 64 megabits, 8 megabytes. 1, 2. Now I'm just double checking these ones are mounted so that they are rotated. Let's get them all ready. designing this, I spent so much time trying to figure out the timing so that I could just do 2 accesses to a 16-bit wide flash chip and only need 1 of these. But I'm glad I didn't stick with that, because this CPLD is about as full as it can get. If in my copious spare time I one day design a successor to this, it's probably going to end up having SD-RAM and a big SPI flash chip. And then I can just steal all the code from the Ultimate Electron upgrade to make those work. But given that I barely have time to produce these and the post boxes, that feels somewhat distant right now. Okay, let's do the Atmel chip. The Atmel chip is completely upside down. Pin 1 is in the bottom right. In here, there's lots of these. As I said in the video about the post box, it's my favorite little microcontroller. 0.8mm pin spacing makes it really easy to solder. Now if you look on Adafruit's boards or the Arduino boards, they'll use the QFN or the 0.5mm spacing ones, but I'm guessing they're not doing this all by hand. I love these little guys. Not as many pins, not as many IOs, but not nearly as many problems when soldering. Okay. I will not mess this up like I did the one in the post box. Yeah. I feel like my solder paste is behaving today. I'm getting to squish things down just right. See, that's something else I like about the BGA chips. Nice straight sides, easy to grab with tweezers. Even this nice little QFP slips off my tweezers, rotates kind of a lot. Okay, now where are we? I see. Alright, let's do this. Okay, here's the buffer. Do we have 4? No. This one comes in a tube. I hardly ever see tubes these days, except for through-hole components. I love mounting these ones the wrong way up, letting the smoke out. This one, pin number 1, is bottom left. There we go. First chip I drop, and it's just a little SO. I believe this is the finest pitch I've mounted so far, a 0.65 millimeter. Come on, little guy. Okay, there you go. So I mentioned earlier that I had a favorite BGA chip, which sadly is discontinued. It was the SN74LVC 16245AZRD, Texas Instruments. It is your bog standard 74LVC 16245, but in a tiny BGA package. Tiny, but not terrible pitch. I believe it's 0.8 millimeter. This is what I used in the Ultimate Electron upgrade, and sadly it got end of lifed. Texas calls the package MicroStar BGA, and their substrate supplier must have end of lifed something, and so they did too. Made me very sad. The Ultimate Electron upgrade has been on hold ever since, because the work of redesigning the board and then soldering them using fine pitch T-SOP instead of easy BGAs did not appeal to me. Okay. Alright, where are we? Now it looks like we've got some resistors. We've got those terrible 0402s. We've got the terrible resistor packs. Oh, we've got some nice easy diodes. Okay, I'm just going to do these ones upside down. What is it? This one goes on the top and it goes on the top. This thing is the S1ATR. This diode is here because I had plans back in version 1 to make it so that you could plug in Arcflash to your target machine and also to a host over USB at the same time, and it would take power from whoever would supply it, and all would be well. Until one day when I switched off my RISC PC, it didn't quite switch off, everything just dimmed, the hard drive made a weird noise, and then that Arcflash never worked again. That was because current was flowing through the other diode, through the regulator, through the FPGA, and out through the data lines, or address lines. So ever since then, I skipped that second diode. Makes it so you need to have the target turned on, but that particular failure mode no longer happens. Now we're getting somewhere. I thought I had some more resistors. Well, it's a bit of a surprise. Guess I'll have to go dig for those. What am I missing? I'm missing 100 ohm, 10k, and 1k. And I bet I'm missing them because they're in this bag here, which is the one with all the stuff for the postcards. What's that? 4k7, 30, 258, 2, 1K, 330, something at the bottom, you, 10K. Alright, there's 1K and 10K, 100 ohms is kind of important. Where that one lives. Yeah, right there. Thought I fitted this all out before this video started. Guess not. Now, I think I thought I saw one of these bumping around. Okay, thankfully no. Alright, which one's easiest? 100 ohms, I need 4 of them. How are we doing for time? 41 minutes, and I haven't even reflowed. Okay, so this is taking rather a lot longer than doing that single post box the other day. But I'll get 4 of them, so I am still happy. Okay, 400 ohm resistors. Oh, which one's that? That is R2, and it's next. Oh, is it? No, it's not. It's R3. Okay, yeah, R3. So this 100 ohm resistor is when we discharge the power on reset capacitor through this little buffer here. We don't want to discharge it too quickly. We also don't want to discharge it too slowly, which is why I didn't just use a 1K and not have to worry about another component type. Talking of 1K, we need 1Ks for something. R2. Where is R2? Must be a pull up or a pull down for one of the SWD pins. 1, 2, 3, 4. We've got a bunch of weak pull-ups in here. Where is it? That was R2. Okay. Is this all visible? Let's get these back in frame. Here we go. R2, where to put that? Yeah, I like using 10K resistors for pull-ups. There's a 10K reset pull-up. I use a 10K pull down on the power line, I think. This was an earlier attempt at fixing that power everything over USB issue, which never really worked, but it's still in there just in case I figure out what the bug was. I think if I ever try to resurrect that circuit, the way I'm going to do it is put in a comparator and only let the FPGA work if the target power is more than 3.3 volts. Anytime it drops below that, it is off, or being powered by us. Alright, where do these 10Ks go? These 10Ks are R1, 6, 7, 8. R1 for reset. What is it? 6 is horizontal. 8 is vertical. 8, 8. Well, I kind of have the feeling that actually I took out that. Oh, I know how it worked. The target power sense used to go straight into the CPLD back when I thought that was going to work. But I think I took it out, but I kept that line, but I think I ran it through that buffer instead. And then this here, this test point, goes to the one spare line, the one spare CPLD pin. I think with 144 pins you wouldn't run out, but no. So very easy. One, 6. Oh, there's 7 up there. 7. One, 6, 7, 8. 1, 6, 7, 8. 1, 6, 7, 8. 1, 6, 7, 8. Great. Okay. That's all the resistors done. BGAs, the buffers. It looks like it's time for the nasty capacitors. We have 7 of them, 8 of them. 8 of them per board. Thought it took a long time to place 48 0805s. Now it's time to do 32 0402s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. Definitely going to lose some of these. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 32. Alright, did I get that just right? I'm leaving this one out because these things are like little grains of salt. Alright, 8 per board. I'm switching my lights on for this. Actually, no, I'm not. It doesn't help at all. I have a really bright light. Right up there. And so it's a little different. This is the sort of thing where if you have a really good overhead magnifier, it's not that terrible. The first time I tried to do 0402s, I tried to do it by hand. I tried to do it by eye with no assistance, and it was such a mess. 1, 2, there's another one, 3, 1, 2, 3, 4, 5, 6, 7, 8. All right. It's funny, you would think you would need really steady hands to do this. But actually you get a couple of tries at most of these, so it's not that bad. It's like being good at typing. You can make a lot of errors and still be fast at typing. Now my wife plays piano and decorates cookies. Those you only get one chance. Dear. I've gotten to the point where my tweezers got a little bit of solder paste on them. Do I have anything around me that I can use to wipe it off? This Q-tip will have to do. 1, 2, 3. 2, 3, 4, 5, 6, 7, 8. And last 8. One, two, 3, 4. 4, 5, 6, 7, 8. Huh. And 1 off. But I think I counted 8 on all of them. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. Okay. We've got 1 spare 402. You can see it there on my fingertip. If it focuses, there you go. All right. We are so close to being done here. So close. We've got the diode. Point them out. We've got the diode, the regulator, the capacitors for the regulator, a bulk capacitor, CPLD and all its tiny decoupling capacitors, the memory and its decoupling capacitors, the buffer, its decoupling capacitor, and the power on reset resistor, a bunch of little pull-ups, microcontroller. We just need USB and those little resistor packs. 1, 2, 3, 4. All right. Resistor packs, it's time for you. Doing this for an hour and I'm starting to get a little tired. Maybe I should have done these earlier, but oh well. 1, 2, 3, 4, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16. There's always a point in any of these little mini batch assembly jobs, and I regret trying to do so many. But at the end, I'm glad I did. I think somebody on Stardot said that these resistor packs are not worth it because it's faster to just mount 8 resistors by hand. I beg to disagree. You see how long it takes to mount 80402 capacitors versus just dropping one of these on. Now I'm going to have to do this out of frame probably. I think it works like this. Yeah, there we go. Is this completely out of frame? Oh, no, oh, not quite. Good. Of course I couldn't. Quite manage to get them all oriented the same way. I'm designing this board, so I have this one awkward one. Let's just, yeah, okay, that worked. There. No way I could do 32 resistors in that much time. This is going to be really interesting. This one is just a giant blob of solder paste. Hope I won't have to break out the hot air to repair this. I also need to put together some kind of automated test so I can tell if I have any shorts during assembly. Sort of thing I should be able to easily do by programming something different into the CPLD. I believe that was originally the point of JTAG. Boundary scan. To make that kind of onboard testing more accessible. Whew. Now, ceremonial mounting of the micro USB socket, and it's time to cook these boards. I have a pile of discarded components on the floor. Just been throwing these things on the ground. I'm done with them. One. Two. Three. And we are done. Okay. Time to get out the hot plate. looking forward to seeing how this comes out on the video. As I've never managed to get a really good video of reflow happening. Hopefully, I won't cook the camera in the process. Oh, look at that. Lovely. You just keep that focus for the 10 minutes or so this is going to take. Can I show for two of them? No, let's not tempt fate. All right. Here we go. Set it to 300 degrees. Cross our fingers. And watch. This is the point where you might want to skip ahead a little bit in the video. There's a lot of watching and waiting. For me, actually, it's a good time to inspect these boards, make sure nothing got misaligned. See if I can use the camera to help me. Okay. I feel like that BGA is a tiny bit off. About this board. I was going to say I made a mess of the flash chip placement, but then bumping them around like that, I don't think that really helped. I'm seeing some smoke starting to come off. Guess that's a good sign. If we're lucky, we'll start seeing some reflow. See, can you see it in? Oh, camera is not happy. Let's just lift that up a bit. Oh, while I did that, the reflow began. So you can see these chips here are looking pretty good. This one here is mostly reflowed. Let's turn that around. How are we doing over here? These ones are all looking mostly nice. Of course, the real question is, when do we say BGA is done? Okay, this feels very hot. I'm gonna swap this one around. Yeah, okay, that one was on the cold side. Turn this thing off because that's a bit more smoke than I like to see. As I said in the other video, you run it until everything's reflowed and until it's smoking a bit, but not way too much. When it starts making you nervous, pick them all up. Stick them off on the side to cool down a bit. Alright, lots of smoke. Let's move this over. That's awful. Okay, can we focus on that? Terrible, terrible reflections, but look at that. Okay, here we are. Well, it's certainly not the most amazing soldering job I've ever seen. Rather blobby looking over on those resistor packs, but the one we really care about, yeah, BGAs are looking lovely underneath. Turn my lights on. Yeah. Alright, it's going to be some fixing to do, but I think our BGAs are going to be pretty happy. If I was professional assembler, I would not take them off to cool so soon, but as a total amateur, I found that it works okay. These things may not last long as a proper one would, but they will probably last long enough to satisfy those of us who are using them in our retro machines. Okay. Okay, let's see. Alright, camera, do your thing. Okay, look, that microcontroller looks pretty nice. Buffer looks like a total mess. Resistor packs need some help. Tiny, tiny capacitors. Yeah, look at those. Those are lovely. Those little CC capacitors there. Those, what, 100 nanofarad 0402s, they worked out just fine. How's this one looking? This one, microcontroller. Focus, focus. Come on, camera. Try again. Yes, okay. Microcontroller. Those pins look okay, okay. Buffer. Little sketchy, not too bad. Resistor packs, manageable. Alright, let's see if you could see down the BGA. Okay, so one glorious half second there. Let's see, I'll put my hand at the right level. If I could focus on my hand, it'll probably focus on the BGA. No. Alright. I'll take a better picture some other time. Oh, yeah, you can see them. You can see the balls under the RAM chip, the flash chips. The CPLD sits rather closer to the board, so harder to see. Alright, here once again. Okay, the micro USB, even not focused, you can see that there's a weird blob there. Up there it is. The microcontroller, this one might need a little rework. Buffer also looks terrible, resistor pack's terrible. BGA is probably fine. How are we doing on this one? Microcontroller, buffers, resistor packs. Oh, this is perhaps the best of the lot. Well, let's get started. Let's not make the mistake I made last time and forget the flux. Am I centered? Yes. Nice. Okay. Okay. Let's. Oh, actually, this microcontroller is looking pretty good. I'm just going to touch. Get this back down. Okay, here we go. There. I remember noticing that one of these boards, there was a buffer that was a little short on solder. I don't think it's this one. Oh, let's check out the micro USB. Actually, this one looks pretty nice. These resistor packs. RP3 is good. RP4 is good. RP2. Oh. Well, these resistor packs looked like I'd made a right hash of things, but actually, I think everything on this board is probably okay. Let's check my assumption. Did I get that right? I'm going to 5 volts, 0.1 amp. 5 volts, 0.1 amp. This board has no there's no LED on it. Oh, let's actually turn that output on. Yes, okay. This board draws 10 milliamps at 5 volts. And that's what I want to see with everything everything disconnected. Can I be bothered getting my scope out for this? No, that's okay. Alright, that's one happy board. Let's see, what have we got here? How's this one? Oh, this one definitely has some problems. This microcontroller has a little solder bridge right there. Let's see if we can fix it without resorting to wick. Did I get it? I did. That one pin looks a little ugly. There. Lovely. That's the only bridge. We do have a bridge on the USB. Out with the wick. Indiscriminate wicking of solder usually fixes these things. And USB looks lovely. Okay, great. So, microcontroller is now good, USB is now good. Buffer. Oh, buffer looks pretty gross. Alright. I predict wicking on every component. Every little component. Definitely that one. Definitely that one. That one. Probably this one. Okay. Let's wick up the failures of this chip. And just touch everything. 1, 2, 5. Oh, that's an odd one. I wicked up some solder and now it looks a little dry. I can go back and forth like this all day. Too dry, not enough solder. I mean, so too dry, too much solder. Too dry, too much solder. That was when somebody from the drag soldering team will probably come out with some good advice. It's something I never got into. I always either solder pin by pin or I reflow a whole board in one go. I tried drag soldering once, destroyed a component completely. Never again. Although, I see everyone's videos, watch everyone's videos with envy, because it looks great when it works. Okay. It's pretty nice now, I think. So let's see if I can demonstrate this. I have this OptiVisor DA4 with this loop attachment. This gives me something like 6 times magnification. When I put this down, it's something like 20 times. It's perfect. You can see anything, but you have to get really, really close. To focus on something, I need to be about here. Okay, where was I? Okay, next one's bad on both sides. Actually, all 3 of these are bad, so... 2. That's pretty nice. Hopefully I have another reel of solder wick floating around somewhere. Getting pretty close to the end of this one. 1. Oops. 2. 3. Okay, those are looking good now. Board number 3. This has indeed a solder bridge in USB. Microcontroller looks great. There's a bridge on the buffer. Another bridge on the buffer. Alright, once again the wick-free approach worked on the buffer. See if I can pull that off on the USB. I think I did. I've got enough flux on these things. Often 2 pins are bridged, you can just run the soldering iron right down the middle and they'll fix themselves. Oop, bridge, bridge, bridge. And a little bridge. Okay. Alright, looks like all these are going to need some work, just like the last one. Okay, so this is the point where that guy who said soldering individual resistors is better might have had a point. Repairing resistor packs, it's no fun. Whereas my 0402s over there needed no repair. So, I don't know. I have the feeling that this is one of those things I could get right if I messed with the footprint a little. I kind of have a bunch of rules of thumb with surface mount footprints for this kind of component, which are all about making sure I can, with the top, making sure I can hand solder them if necessary, but on boards like this, components that are not hand solderable at all, I should optimize for getting the reflow footprint just right instead. If I can ever figure out QFNs, maybe one day I can design a board with one of the Raspberry Pi Foundation's awesome new 2040 chips, which, in an understandable but frustrating decision, I chose to only put out in 0.4mm QFN. And as you can see, my track record with 0.5mm pads is not amazing. Don't even want to try 0.4 until I get a bit better at that. That without wick, but it's just going to look a whole lot better if I do actually remove some of that solder. There we go. Okay, I have 4 circuit boards. Now, I still have my power supply set. Let's see what we get. This one is the power pin, wasn't it? 0.01 amps. Double check. 0.01, great. 0.01. And 0.01. Well, there we have it. 4 Arcflash version 3 boards. I'm going to zoom back out because this deserves a shot with all 4 of them. So how long that took. You see why I still haven't delivered them to everybody. The next step here is to take each one of these boards, plug in an ARM SWD programmer into this tag connector here, program this microcontroller, and then plug in a USB cable, program the bootloader into the microcontroller using SWD, and then program the actual firmware into the microcontroller over USB, followed by use the microcontroller to program the CPLD by dumping the SVF into over its JTAG interface, and then microcontroller plus CPLD together to program the flash. If that all works, there's a good chance that this will work when you actually throw it in a real-life Archimedes board. So at that point, I solder on all these pin headers, of which there are many. I solder on all of those pin headers, and I solder a bunch of pins in here, most of which end up just being jumpers, but use that to configure the machine you're on. A305s and A310s, you need to solder in pins and then run wires from those pins to various points where the address lines are accessible on the motherboard. A3000s, A3000, A5000, you can generally just put a bunch of jumpers in and jumpers straight across. A5000s are the best because they have the LA21 line. Yeah, well, fingers crossed. Thanks for bearing with me. This took an hour and a half. So just under double the amount of time to make one postbox board, so I guess that was okay. You could see we just mounted 12 BGA chips. Looks like I've destroyed one webcam from the heat. It is glitching like mad right now. That's fun. Happier? Yeah. Oh, there it goes again. Well, goodbye C922. So yeah, time to do some programming. See you next time.